All right, hello, and welcome back to the Agents Unleashed podcast, a show that helps you to sort signal from the noise in the fast-paced world of agentic AI. I'm your host, Thomas Maybrier, and I'm a producer at Valerie, one of the core contributors to Olas, who sponsor the show. Olas is the best way for anyone to own and monetize an AI agent. You can learn more about how to do that at olas.network. This week, we're going to take a look at a serious new security threat that's escalating faster than most people realize: prompt injection. You've probably heard about hallucinations, where an AI confidently makes up or returns irrelevant information. Prompt injection is different and often more dangerous. You can think of it as the AI equivalent of SQL injection or cross-site scripting. It happens when an attacker places hidden instructions inside a prompt or a piece of content. When an AI system processes this content, it follows the attacker's instructions instead of your own. One of the most dramatic demonstrations of this came at BlackHat this summer, where researchers unveiled something called agent flare. Here's the scenario that they described. Imagine you've connected ChatGPT to your Google Drive via the connectors feature. An attacker shares a document that looks normal to a human but contains a hidden white font prompt embedded in Markdown. The AI reads this text, executes it, and then leaks things like API keys or SSH credentials without the user ever clicking or approving anything. Simply loading the document into the AI's context window is enough to trigger the attack. It's not limited to ChatGPT either. The security firm Zenity exposed that these zero-click exploit chains may target tools like Cursor and even enterprise AI agents like Microsoft Copilot Studio and Salesforce's Einstein. The OWASP Gen AI Security Project's Top 10 Risks report named prompt injection as the #1 risk for LLM applications in 2025. This is a structural challenge, so mitigating it will involve more than just keyword filters or adjustments to training. Even worse, the attack surface is expanding. Researchers at Hidden Layer have advanced the concept of an AI virus with a new attack called the copy pasta license attack. By embedding a malicious prompt in a hidden comment, the attack tricks the underlying model into believing that it's a vital license file that must be included in every file the AI agent touches. This allows malicious code to replicate itself and introduce deliberate vulnerabilities across entire code bases with minimal effort. Unlike earlier theoretical AI worms like Morris 2, which were limited to data exfiltration and easily spotted by humans, copypasta is more effective. It targets agents that generate executable code and disguises itself inside licensing boilerplate, which most developers are conditioned to ignore. That eagerness to respect software licensing conventions is exactly what makes it so insidious. So, if you were a security reviewer for a dev team, how would you realistically detect and stop something like the copy pasta license attack? The answer is that you don't put blind faith in a single tool. For security and code reviews, some teams rely on independent processes that are separate from the development tools themselves. This means that the coding agents aren't also used as security tools. Instead, you use a combination of automated and manual checks. Automated checks like linters and static analyzers are configured to enforce coding standards. These would raise an error if a malicious line of code, like the one in copypasta, suddenly appeared at the top of a file. Manual reviews by competent human reviewers act as the final line of defense, catching odd or out-of-place code that automated tools might miss. Another approach is to use AI agents for defense, although not the ones you used for the coding. Multi-agent systems allow for security AI agents, explicitly assign the role of a security reviewer, to be added to a larger set of tools for code review. For example, at NVIDIA's GTC conference, CrowdStrike demoed a multi-agent red teaming system where specialized security agents continuously probe AI-generated code for vulnerability, essentially running a live adversarial review process alongside development. Similarly, Endor Labs has launched an AI security code review platform that employs a team of specialized agents, including a dedicated security agent, to analyze pull requests, contextualize code changes, and flag potential risks before they hit production. This kind of rigorous, cautious approach to code points to a new reality of the modern AI era. All untrusted data entering LLM context should be treated as potentially malicious. Of course, manual inspection of every input at scale just isn't possible, so that's why organizations must implement systematic scanning for embedded malicious instructions and data sources, even when those instructions are disguised within seemingly legitimate content. Prompt injection isn't just a simple bug. It's the biggest systemic threat that we've seen in AI yet, and it's one that escalates every time we give agents more power to act autonomously. Just to recap, here's a couple of reasons why. As I mentioned before, the attack surface has expanded. As AI agents integrate with file storage, email, calendars, code repos, they do become powerful, but they also become more vulnerable. The manipulation is invisible because the injections hide themselves inside or behind ordinary-looking content. The attacks are zero-click, which means that the users don't have to do anything. The AI gets tricked automatically. Because the malicious content is cloaked, the user can't tell that there's something wrong. By definition, AI agents have the ability to act in the world, and they do more than just answer questions. Using tools, they have the ability to access calendars, file systems, email, code repository, and they can also fetch data, schedule tasks, write pull requests, and even execute trades. A compromised AI agent could cause significant harm, especially if it's able to act on-chain and control assets. Now, the impact isn't just limited to misinformation. You could be looking at drained wallets, unauthorized trades, or corrupted records. Researchers at JFrog call this the difference between misinformation and weaponization. Once an agent can act, every prompt injection becomes a potential exploit chain. So the question is this: how do you make agents actually secure enough to trust with real responsibility? There's no single answer to this question, so here I want to put the focus on the way that Olas answers this, which is that you don't put blind faith in a single model. Instead, you build the system so that security is a part of the design. Olas agents aren't purely model-based, they combine rules-based and learning-based AI. For example, the predict agents that we've talked about in previous episodes use AI workflows to predict the future. While prompt injection could theoretically happen here, the open source nature of the code reduces the likelihood of malicious inputs. Furthermore, inputs and outputs to the workflows are sanitized, and predictions are only used by a single agent. The agent then uses a probability measure to place a bet as a part of a rules-based process. In the worst case, the agent might place a less than optimal market bet for a specific market, but it won't suddenly transfer all of its assets to an attacker. The workflows are open source and they're used by many agents so they can be continuously evaluated for their effectiveness. Agents learn whether certain workflows are good or bad once markets resolve, which mitigates the risk of individual prediction workflows degrading. Olas, like others, is looking into further improvements to the architecture to counter evolving threats. So what other ways does a system like Olas Predict and Olas agents more general handle these risks? We can take a look at some of the design principles underlying Olas to get an answer. Instead of marketing claims or closed dashboards, you get an auditable record of who placed which bets, what they staked, and how often they were right. This is the foundation of trust minimization. You don't have to take someone's word for it. You can just check the on-chain action of the agents and review the open source code underlying the agents yourself. Another path is through the discoverability and accountability of the Olas native agent marketplace, also called the MEC marketplace. The marketplace allows you or your agent to discover other agents and hire them for their services. The public nature of the blockchain makes it possible to check its on-chain history. For example, like with this predict agent, where it's possible to see how well it's traded in the past. Or you can see what other agents have used it and paid it for. This ability to outsource is important because agents don't work in isolation. Instead, they often need to hire other agents for specialized tasks like data processing, media generation, or research. All those hires are logged and settled with crypto payments. That means you can actually trace the supply chain of agent work. If something looks suspicious, you can see which mechs were involved and then decide whether to trust them. When you combine these pillars, you can start to see how Olas handles risks, including those presented by prompt injection, differently. There's a few more design choices underlying Olas agents that I think are illuminating here. First, as I mentioned earlier, Olas agents intelligently combine rules-based logic with learning-based systems. The learning side is where you get adaptability and reasoning, but it's always married to rules that define the boundaries of what the agent can and cannot do. That combination means that agents can be flexible while still operating inside a framework that allows developers to make more explicit choices about the predictability and safety of the overall system. Second, any wallet interaction is rules-based by design. The learning system decides whether to take an action and how, for instance, large that action should be, but the execution layer enforces strict guardrails. Only developer whitelisted protocols and approved on-chain methods can go through. Olas uses an on-chain architecture based on safe smart accounts, which separate the signing key from the on-chain account itself. That account can be further constrained with transaction guards if needed. Third, every action leaves a trail. If an injected prompt pushes an agent to make a bad move, that move is recorded on-chain. You can audit it, measure the impact, and penalize the operator if needed. That creates accountability for what that agent does. Fourth, dependencies are transparent. As I mentioned earlier, agents rarely work in isolation. Those calls are also logged and visible, so if your agent relied on a malicious mech, you can trace it, cut the connection, and adjust. In fact, even your agent can, and in the case of Predict, does, as discussed before. That creates accountability for the agent's supply chain. Lastly, the whole thing is open source. If you want to inspect the code or swap out components for your own hardened versions, you can do that. So does this eliminate the threat of prompt injection completely? Well, of course not. You still need classic guardrails like input sanitization, output validation, and compliance filters. But the Olas model presents a developer with the ability to make trade-offs in how rules-based or learning-based they want to make their agent, thereby creating increased security by design. Instead of just hoping that your agent is safe, you can actually verify that it's behaving as designed. If it doesn't, there's an economic and operational framework to make sure that the costs land where they should. Okay, that was a lot, so that's all I have for you this week. If you like this week's episode, the best way to support me is by sharing this episode with a friend or a colleague who's interested in agentic AI. You can also take the listener survey that I'm running over the next couple of weeks. I'm going to be collecting your feedback on the show, and one lucky respondent will win 500 Olas tokens, subject to some terms and conditions. You can find a link to take that survey and links to all of the things that we mentioned on today's show in the description box on YouTube or the show notes. One last thing. Agents Unleashed isn't just a podcast, it's also the premier event series for people interested in agentic AI. The next event is actually right around the corner. It's going to be held October 1st at the Art Science Museum in Singapore. It is free to attend, but you do need an RSVP. I would recommend that you grab one now because the previous event at the Art Science Museum was standing room only. You can find out how to do that at olas.network/agents-unleashed or grab the link in the description box or the show notes. All right, thank you for joining me. This has been the Agents Unleashed podcast, and I'll see you next time.